Hi, my name is Michael, and welcome to my 2D action and adventure RPG tutorial series. We are learning how to build a top-down 2D game that features action, adventure, and RPG mechanics all in Godot 4 using GDScript. In this video, we're going to take our simple character controller that we created in the previous tutorial and improve it by adding animations for the walk and idle states and making the character face the direction that you press. So let's take a peek at where we left our project off. I'm going to go ahead and just run this. We've got our player, and he can move kind of like this, kind of lame. So we're going to add those animations. Now there's a couple ways we could add the animations. We can use an animation player, or we could use an animated sprite 2D node. The animated sprite 2D node is a simpler option for animating a sprite. It's very simple to set up, but it comes with some drawbacks. And while the animation player is slightly more complex, its extra functionality is pretty robust, and it's not that much more difficult to use. So that's the choice I've decided to use for this project, so that we have the option to be able to animate just about any conceivable piece of a player. And also, before we get into adding the animations, I'm going to go ahead and put our player right in the center of the screen here. That way he won't be starting on the top corner. And before we edit anything on our player, we need to make sure we're actually editing the player scene. So go ahead and click on that and get your player scene open here. In our scene tree, we don't have what we need yet to be able to create animations, because we need that animation player node that I mentioned. So let's go ahead and add an animation player node, and that's usually visible right here. If you don't see it, go ahead and type it in the search. And there we go, there's our animation player. And once we select the animation player, you'll see the animation options appear in the bottom panel. And it's pretty empty right now, so let's create a new animation by clicking Animation, New. And we're going to call this idle underscore, I don't want all caps, idle underscore down, all lowercase. This naming convention is going to be important for later on when we go to hook up our animations in our code. So we're going to have 3 variations, idle down. We'll start here. We now have a timeline, but nothing to animate. There's 2 ways we can start adding keyframes for this animation. One would be to click Add Track, and then pick the type of track. In this case, we would be animating the frame property on the sprite 2D, so you could click Property Track, select Sprite 2D, say OK, and then find the frame property and say Open. And I'm actually going to cancel that and show you an alternative way. While we have the animation player selected and the UI displaying in the bottom, we can go over to our Sprite 2D. Notice it stayed on the animation player, and when we look at the inspector for our sprite, I'm going to animation player Y displaying in the bottom. We can go over to our Sprite 2D. Notice it stayed on the animation player. And when we look at the inspector for our sprite, I'm going to expand the animation options. You'll notice a little key icon appears next to each property. So we can just find the key next to frame and click plus. And it's going to ask us if we want to create a new track for this. Let's say create. And there we go. That's the same outcome as if we had finished the previous. Let's say create. And there we go. That's the same outcome as if we had finished the previous process of going through the add track interface, but just a different way to get there. I'm going to zoom in, control scroll wheel to zoom in. And I'm going to go ahead and create the keyframes we need for the idle animation. I'm actually going to zoom in more. There's only 3 frames on this one. It's quite simple. It's meant to loop in a ping pong fashion. So we'll go here, we can right click, insert key. And when we select that keyframe by left clicking on it, you can see there's a value up here. The first one, when we added it, was that keyframe. So we'll go here, we can right click, insert key. And when we select that keyframe by left clicking on it, you can see there's a value up here. A ping pong. I'm actually going to zoom in more. There's only 3 frames on this one. It's quite simple. It's meant to loop in a ping pong fashion. So we'll go here, we can right click, insert key. And when we select that keyframe by left clicking on it, you can see there's a value up here. The first one, when we added it, was at 0. The second one should be on frame 1. And then we can come here and insert one more on this one, it's quite simple. It's meant to loop in a ping pong fashion. So we'll go here, we can right click, insert key. And when we select that keyframe by left clicking on it, you can see there's a value up here. The first one, when we added, it was at 0. The second one should be on frame 1. And then we can come here and insert one more key, select it, change it to 2. And then if we hit one of these buttons here, this little play up here, the first one, when we added, it was at 0. The second one should be on frame 1. And then we can come here and insert one more key, select it, change it to 2. And then if we hit one of these buttons here, this little play button with a line on it's going to play from the beginning. You saw a little bit of a wave there. Obviously, we need this to loop, and we've got a lot of empty space. So in order to fix that, let's just crop down our timeline. It's only 0.2 seconds long. So we can change the duration right here in the top right corner of the animation interface. Type 0.2, press enter. And then we're also going to click this little button. It's got these circular arrows. This is for repeating. And I'm going to show you what that looks like. Now, we actually don't want it to repeat normally. Like I mentioned, these particular animations were designed to be ping pong. So if I change that, click that one more time, you'll see a different type of looping. You can see what the playhead's doing, moving from left to right and back. And now we get a little bit more of a natural animation on this. And I'm actually going to do one more thing. I think 0.2 is a little bit fast for that. I'm going to change it to 0.4, double the duration, and then plot these guys, space them evenly. I think that looks about correct. Let's see how that looks. Okay, a little bit more calm. I like that. So now that we've got this one idle animation created, it's going to be pretty quick to create the other ones. We're going to click on the animation while we're on idle down. Click on the animation menu and select duplicate. And we'll rename this to idle_up. And then And I'm going to duplicate this one more time and call it idle underscore side. And those are the three. And then I'm going to duplicate this one more time and call it idle underscore side. Duplicate this one more time and call it idle underscore side. One more time, idle underscore up. And then I'm going to duplicate this one more time and call it idle underscore side. And those are the three animations we'll need for our idle state. You're probably wondering why we don't have an idle left or an idle right. The reasoning is we're going to have a single animation for left and right. We'll simply flip the sprite. This saves in animation work needed to be done because you don't have to create a separate, sprite sheet for the animations for left and right. However, if you wanted to have a left and right animations look more distinct, you could draw those out and create both of those animations at this point. But bear in mind that that incurs a greater cost when producing the artwork. So for our idle side animation that we're on right now, we need to update the frames, of course. And the idle side animation, let's see, it starts at frame 14. Let's go ahead and hit play so you can see this while I'm editing it. 14, 15, and 16.
Oh, so that did that shit by itself. Oh my god.
Okay, there we go. There's our idle side. And let's set up the keyframes for idle up, which are keyframes 7, 8, and 9. Okay, there we go. We've got our idle animations. So now we can set up our walk animations. So I'm going to switch to idle down. I'm going to duplicate the animation. I'm going to call it walk underscore down. And we'll just start with just the walk animation. I'm going to switch to idle down. I'm going to duplicate the animation. I'm going to call it walk underscore down. And we'll just start with just the walk down. I know based on previous testing, I want these keyframes closer together and our walk down. I know based on previous testing, I want these keyframes closer together and our walk animation has 4 keyframes and the duration is 0.3 seconds. We just need to update the actual keyframes. So the keyframes for the down animation, if you're using the sprite I provided, are 3, 4, 5, and 6. So I'll go ahead and update those now. And then we can hit play. There's our walk animation. Once again, this walk animation was designed to be a ping-ponging animation, goes back and forth. It means we get 8 frames. And then we can hit play. Those now. And then we can hit play. There's our walk animation. Once again, this walk animation was designed to be a ping-ponging animation, goes back and forth. It means we get 8 frames of animation out of 4, and it looks like a complete walk cycle. You don't have to do it this way. I did it this way to be simple and prep this artwork easily for the tutorial, but obviously you could make an 8-frame animation cycle of your own and import it or do whatever you want. Let's go ahead and duplicate this walk animation now to create our up and side versions. So we'll do walk, side, duplicate, walk up. Okay, so for the walk up animation, the keyframes are 10 through 13. Okay, we play this animation. Looking pretty good. Swap over to walk side. And the keyframes for the side are 17 through 20. All right, there we go. We've got our 2 animations with their varying directions. So a total of 6 animations here. You'll notice that when we created our first animation, it also set up this reset animation, and it's just a single frame animation. So that's kind of handy because the reset is the default animation it'll turn to when you're in the editor typically. Okay, we're all good with our animations. Now we're ready to start improving our player controller and making him actually move. And let me zoom in just a little bit on the code viewer so that we can get as much real estate out of that as possible. And hopefully it's easier for viewers to read. How about one more? Okay. So we're going to need to add a couple things to our script in order to animate this and improve what we're doing here. We're going to need some more variables, and we're going to need to reference a couple of our nodes. So let's start by adding a few variables. The first variable we're going to want to add is going to be called cardinal direction. Keep in mind, this is how I devised to do this, and it's based off of my crazy brain. So hopefully at the very least you learn some new ideas from this if you're new. And if you think of a better way, then more power to you. Go ahead and do whatever works for you. And by default, I'm going to set this cardinal direction to vector 2 down, because that's the direction our character is kind of facing by default. That's not super important, but it, you know, whatever. Vector 2, it is what it is. And you'll notice that I always strongly type my variables. Best I understand, that's more performant for Godot, but it also just makes it so that you get better code completion hints, and there's less confusion when you're looking through your variables later on. You know exactly what type of variable they are. Removes the confusion. I'm going to add one more variable here called direction, and this is actually a variable that we already had created last time. I'm going to go ahead and set this to vector 2.0 while I'm talking. Okay, so this direction, you'll notice in our process we have var direction showing up here. I'm going to just delete that. The rest of the code stays the same, but now instead of the direction being a variable within the scope of the process, it's in the scope of the script. So our other scripts will be able to access this direction variable now. That's what that changes. So being a variable within the scope of the process, it's in the scope of the script. So our other scripts will be able to access this direction variable now. That's what that changes. So to explain that just in another way, when we declare the variable inside of a function like this, then other functions do not have access to that variable, okay? Because it's local to the function within which it was created. But by putting it at the root level of the script, any new functions that we create can also access that. So that's gonna help us quite a bit, actually. I'm gonna add one more variable here called state, and this will be a string. This isn't the best way to handle states, but that's because in our upcoming video, we're gonna tackle a proper state machine for our player. So this is just kind of a holdover, a way to get us kind of going. And then we're gonna create some special variables here that we haven't looked at before. They're called an onReady variable. In Godot, it means we're going to reference a node, and before the script starts, we want to make sure we've got that reference to that node so that we can use it in our code. And you can create these manually, but there's actually a really easy way to create an onReady variable. And the first one that we'll want is our animation player. So if you click, hold Control, and drag that into the script and then let go, it created an onReady variable. It named it animation player, which is let go. If you click, hold Control, and drag that into the script and then let go, it created an onReady variable. It named it animation player, which is just, a different version of the name in the scene. And I'm going to go ahead and add the type of type animation player. There we go. Now we can access our animation player through code. We also are going to want a reference to our sprite. So I'll do the same thing. I'm going to control drag it. I don't care for the sprite 2D. I'll just call it sprite, but I will add the type of sprite 2D. And I think that should be enough to get us going here. So we're going to go down to our process, and we're going to add a little bit of code here, and we're going to add a few new functions to our script. The first change that we're going to make is we're going to add some of these functions actually before we add them to our process. Essentially what we need to do is we need to set a direction on our character, update the state that the character's in, right? Are they idle, standing still, or are they walking? And then thirdly, we need to update the animation. So I'm going to go ahead and just create some functions. Function set direction, and I'm actually going to make this return a bool. And if you don't know what that means this function is expected to return a value, and a boolean is a true or false, right? So at the end of this function, it needs to end with return and then a value, true or false. Okay, I'm going to just say return true for now. And then let me just set up these other functions real quick. So we said we needed a function to do what? Set the state, I think would be next. Set state. And this I'm going to also make return a boolean. This is maybe not super standard practice to make these return something, but I have a particular reason for doing so that will come to light as we work on it. And then the last function I said we wanted was to update the animation. So func update animation, and this one does not need to return anything, so void is good. And I'm going to put pass. Now, if you don't put return or pass at the end of a function and it's empty, you are going to get an error. So I'll go ahead and delete that and just give it a second. You see how we get this error down here? Expected an indented block after a function declaration. So until you're ready to add your code, if you know you need a function name and you just want to put it there and be able to reference it elsewhere in your code, you just type pass, and it's just not going to do anything. But now it's a function, so we can come up here to our script, and we could say update animation, right? Oh boy, if I could type, it would work. There we go. So that update animation function exists and it works. That update animation function exists and it works. So we can put it in our code. We're going to start actually, I think, with our update animation. So here is going to be pretty simple. We're just going to take our animation player, which reference we got with the onReady, and then there's a function in the animation player called play. And as you would guess, this is going to let us play an animation. And as I start typing, sometimes you get hints, sometimes you don't. I'm going to just type idle down. And if I did that right and hit run, our player should be idling. Looks like he stopped. I'm not sure why he, oh, I know why he stopped. Because we're trying to set the animation over and over. It started to work. But don't worry, let's get this going and it'll work a little bit better. We're actually going to update what this says, because we need this animation to be dynamic. So here I'm going to type state. You remember we created the state variable and it's a string. By default, it's idle. That's the first part of the animation name, right? Idle, which is why I named it the way I did. And I'm going to do plus, and underscore. So you do plus and then quotes and underscore. So we're going to add to the string. We're going to take the state string. We're going to add underscore, and then we're going to add one more string. And that's going to be the direction. We can start with just down, a string of down. And obviously we could write that in here. I'm going to do it separate because we're going to actually replace this with a dynamic variable later. We're going to use a function to set this. In order to set this part of the variable correctly, we need to know which direction our character's facing. That's the use of the cardinal direction variable that we created earlier, right? If you remember, the first one we created, cardinal direction, it's vector 2. We're going to convert that to a string. So let me create one more function to do that. Func, we'll just call it anim direction. And this needs to return a string. And a string is with a capital S. Okay, so when you call this function, it's going to give back a string, right? So let's say if cardinal direction equals vector2 dot down. Okay, that's one of the directions we might have on there. Then we're going to just return the string down. Making sense, right? Else if, and in Godot it's elif cardinal direction. Now to do equals in these comparisons, it's two equal signs. I don't know if I said that earlier. So if it's vector 2 dot up, what's it going to be? We're going to return up. Else, now we could do another check here, but actually, if it's not up or down, it's either left or right. So we're not going to, remember, because we have an animation that we're going to flip, we're simply going to return side if it's one of the others, okay? Now what we can do is we can take this animation name, and we'll copy it, highlight this down here, delete it, and paste it in place, just like that. So theoretically, if everything works right, he'll still be facing down in idle animation. Whoop, and you saw the cape wave a tiny bit, hopefully. It's getting stuck, but we'll get there in just a moment. It's having a hard time because I think it's constantly trying to update the animation. And we're actually not going to update the animation every process. We want to be a little bit more smart than that. And that's why I wanted these set direction and set state to return a Boolean. So when we try and set the direction, for example, if we actually change the direction, then this will return true. And then we'll know that we need to update our animation. But if we don't change the direction, it'll return false, which means we don't need to update our animation, right? And same with set state. So if either the state or the direction change in any given tick, then we need to update our animation. But if both of them stay the same, then we're not going to change our animation. I hope that makes sense. And we'll go ahead and start implementing that. And we'll start with the set state function because it's a little bit simpler. So here in update state, we're going to declare a new variable called new state, which will be a string, and set it equal to idle if the direction equals vector 2.0. That means the player's not pushing any direction. It'll be idle. Else, we can say walk. So this is a special kind of operation. It basically takes an if-else type of statement and condenses it into one line. You don't have to do it this way, but there you go. It's a fun example. You know, you could just say, you could change it to look like this. If direction equals vector 2.0, then you could say new state equals idle, right? Or something like that. But in this case, you notice I stored it as new state because we haven't actually set the state yet. And here's why. Remember I said if the state doesn't change, we don't want to necessarily update the animation, right? So if new state is equal to state, that's whatever the current state is. So if they are the same, then we will return false. And that'll be the end of that function. Else, if they are not the same, actually, we don't need the else. We can just say, right, if this condition passes, it's going to return false. Except I got to spell state correctly because it has two T's. Okay. So if that doesn't pass, then we'll just set state to the new state and return true. Okay. So here we go. Let's try this here. Let's say if update state, I'm going to put this function name in there and return true. Okay. So here we go. Let's try this here. Let's say if update state, I'm going to put this function name in there, right? Kind of interesting, right? That returns a value. It's going to either equal true or false. So if it equals true, then we'll update the animation. I must have spelled update state wrong. Where is that? We'll update the animation. I must have spelled update state wrong. Where is that guy? Oh, I called it set state here. Wow, look at me go. Okay, so if set state equals true, there we go, much better. Let's go ahead and run that. Oh, look at that. When I move him now, he's either walking, and when I stop, he's idling. Okay, quite cool. I like that. So we're getting some progress already, right? So we just need to add the directionality, like which direction is he facing? Okay, so that's what this other method is for. And I'm going to actually go ahead and add this here. Okay, so he's idling. There we go, much better. Wow, look at me go. Okay, so if set state equals true, there we go, much better. Let's go ahead and run that. Oh, look at that. When I move him now, he's either walking, and when I stop, he's idling. Okay, quite cool. I like that. So we're getting some progress already, right? So we just need to add the directionality, like which direction is he facing? Okay, so that's what this other method is for. And I'm going to actually go ahead and add this here. I'm going to add, oh, look at that. When I that. Oh, look at that. When I move him now, he's either walking, and when I stop, he's idling. Okay, quite cool. I like that. So we're getting some progress already, right? So we just need to add the directionality, like which direction is he facing? Okay, so that's what this other method is for. And I'm going to actually go ahead and add this here. I'm going to add two conditions. Two lines in an if statement is like saying or. So if set state equals true, or what was it? Set direction equals true. Okay, so now there's two ways that we would update the animation. So we've added our set direction here. Right now, it's always returning true, which means it's always going to be updating, and that's going to get kind of funky again. Might not work very well. Yeah, it's going to get stuck. Well, let's go ahead and fix this up. So set direction. This one is going to be just a little bit more involved, so bear with me as we go through it. Okay. It's going to be similar in that we're going to declare a variable of new direction, and this is a vector2, and we'll set it to the cardinal direction. Okay. We're going to use the reason why we're setting a new direction and setting it to the cardinal direction is we're going to iterate on this new direction. And if it hasn't changed from the cardinal direction after our code, then we're going to return a false, right? No change in the direction. Otherwise, we'll return true. We're going to add a check in here, first of all, to see if the direction is vector2.0. Because if the player is not pressing a direction, we don't want to try and change the direction. Meaning if he's idle, he's going to stay the direction he was when you were walking. Okay, so in this case, we will return false. And then next, we're going to do some code here. Now, this little conditional check that we're going to do is essentially going to say, you know, if you're moving left or right, then let's face that direction. Or if you're moving up or down, then let's face that direction. Okay. And the reason why we can't simply take the direction is because I'm trying to get a direction up, down, left, or right. But the player could be pressing both up and left. And that direction is diagonal. It's right. We have to decipher between the two, and we have to have a way to choose. And again, there are many ways to do this. This is the solution I decided to implement and came up with. And if you don't like it, you don't have to use it. So if the direction y, the y component of the direction, meaning up and down, right? If that is equal to 0, then we're going to do this. We're going to say that the new direction will equal vector2.left if direction.x is less than 0. Okay. A negative x is a leftward direction. This way, if you're on a thumbstick, you know, you got your PlayStation 4 controller and you're pressing like a diagonal direction, the left component of that diagonal is going to be something like 0.7, right? Or it could be any random number. It's not going to be a 1. Vector left, let me just write this below or above. A vector left looks like this. Oops, 2, vector 2, negative 1, comma 0. So you see how the x component is a full 1. Now, like I was saying, if it was a diagonal direction, this could look like negative 0.7, and this could be like, I don't know, 0.4, something like that. If they're on a thumbstick, you're not going to get a vector. That's not a vector left. A vector left is strictly that. Okay. And now another thing about this code is if you're using only a keyboard, this is overkill, because if you're pressing left on the keyboard, it's going to be a negative 1. And if you're pressing right, it's going to be a 1. So we're kind of doing some extra work on this so that we can account for using control schemes that might give you different directions than just left, strictly left or right, right? Does that make sense? So again, this might feel like a little bit overkill, but it's kind of helping to avoid an issue in the future. So back to this line of code I was writing. Sorry for that long tangent. So we've got our new direction. If the x direction is less than 0, then we're going to say it's a vector left. Otherwise, any other direction that we have in there, because we already know that the x is not 0, and in this case, the y is 0, right? So in this case, we're going to say that's vector 2 dot right. Okay. And then we'll do an elif. We'll say if the direction dot x equals 0, we'll go new direction equals vector 2 dot up. If direction y is less than 0, else it's a vector 2 dot down. Oh boy. Okay. Now, hopefully what this will do is it'll make it so that we're always facing one of the 4 directions, up, down, left, or right. And it's going to account for some potential odd variables in the middle, like if you've got a thumbstick, and then hopefully it'll just work good. Now we're going to do a check here. I mentioned that we don't want to change if the direction hasn't changed, right? So if new direction is equal to 2 equals cardinal direction, if they are the same, we'll just return false. I'm not going to do anything else. But if they're different, then we'll go ahead and set the cardinal direction to the new, oh boy, the direction. The new direction. And we're actually going to do something else here. Remember how I said if you're facing left or right, we could flip the sprite? There's 2 ways we could flip the sprite. Let me show you. When I select the sprite 2D and I look at, where is it, offset, there's a flip horizontal and a flip vertical. We could toggle this on when they're looking left and off when they're looking right. And that works perfectly fine for probably a large portion of use cases. I'm going to do something different. There's another alternative. Instead of flipping the sprite, we can actually scale the sprite on the x-axis. Now, the reason I would do this, the reason I choose to scale it instead of flip it is, okay, let's get this guy here. Let's say we had this thing that was attached to the character and it's on the right side. Okay, it's a separate sprite. If we flip this sprite from left to right, then this guy's going to stay over here where it is. But if we wanted this to flip with it, then what we could do, I'm going to go ahead with the sprite 2D selected, the parent object. In fact, let me just show you. If I flip it, sprite flips, okay? If I transform it, and I'm going to unlink the directions here, and I scale this to a -1, they both flip. Pretty cool, right? So that could be useful if you have child objects that you want to flip with it. And I think I'm going to want that in the future, and I think you might too. So let's go ahead and do that. Instead of flipping the sprite, let's scale it on the x-axis. That's actually pretty simple. We got a reference to our sprite. We'll say sprite.scale.x equals -1 if cardinal direction equals vector 2 dot left, else 1. Oh my gosh, did I get that right? Okay, there we go. Does that make sense? So if our cardinal direction is left, then the sprite scale is going to be -1. Otherwise, it's going to be 1. Okay. And then, of course, at the very end of this, we did change our direction if we made it this far, so we return true. So we've got this piece of code up direction if we made it this far, so we return true. So we've got this piece of code up here already, right? You guys think this is going to work? I'm going to go ahead and press F5. Let's see what we get. Ooh, it's walking. It's walking. And you notice when I stop, he idles in that direction. And now I'm holding left and pushing up and down, and he's going to maintain that direction that I initially pressed. Okay, seems to be working pretty good, I think. So there we go. We've got a moving character with some animations, some directionality tied into it all, and a little bit of sloppy code in there maybe. But next time we're going to work, okay, because it's low table, is this is maybe not super standard practice to make these return something, but I have a particular reason. You see how we get this error function update work. There is going to be guess. This is going to let us play now. I'm going to just looks like he stopped trying to set the animation over and over. It starts update dynamic. By default, it's the way I did. And so you do plus add start with just down a dynamic. That's the use of cardinal to do that. Func. We'll just call it anim direction. And this needs to return cardinal direction equals we might have on there. Making sense, right? Else if, and in Godot it's elif cardinal direction. Now to do equals in these comparisons, it's two equal signs. I don't know if I said that earlier. So if it's vector 2 dot, but actually gonna remember just like that. So theoretically, if everything works right, he'll still be facing down in idle animation. Whoop, and you saw the cape wave a tiny bit, hopefully. It's getting stuck, but we'll get there in just a moment. It's having a hard time because I think it's constantly trying to update the animation. And we're actually not going to update the animation every process. We want to be a little bit more smart than that. And that's why I wanted these set direction and set state to return a Boolean. So when we try and set the direction, for example, if we actually change the direction, then this will return true. And then we'll know that we need to update our animation. But if we don't change the direction, it'll return false, which means we don't need to update our animation, right? And same with set state. So if either the state or the direction change in any given tick, then we need to update our animation. But if both of them stay the same, then we're not going to change our animation. I hope that makes sense. And we'll go ahead and start implementing that. And we'll start with the set state function because it's a little bit simpler. So here in update state, we're going to declare a new variable called new state.
It's getting. Oh my god. There it is.
Which will be a string. Let me just set up the created last time. I'm going to go ahead and set this to vector 2.0 new direction. If I want to change using control, take the direction is because I'm trying to get the direction is we're going to iterate on this the animation. That direction equals true. Okay, so now there. characters in, right? So I'm going to turn true. And then this isn't the best way to handle statement. And then there's actually, and I'm going to go functions. And if you don't know tutorial 17, I'm actually I create process, then more power to you. Go ahead and do whatever works for you. Sloppy code in there, maybe. Just all this function within which it was a function. When we declare the variable inside of a function like this, then other functions do not have access to that variable is in the scope. So this a very bar direction showing up here. I'm going to just delete that.